So we've got our delta position. What is that useful for? What do we want to find out? What is our end goal? Okay, here's an example. Let's say, for example, we have a game where someone's got their AR phone, and we want them to walk at least 5 meters away from their starting position. I don't know. Yeah, you want them to get them exploring or something. Okay, so what we need to find out is, have they moved 5 meters? The delta position can work that way, but also can't. I'll show you what I mean. So let's say, for example, we've got our little dude at position 2, moves over to position 5. Now our delta x, if this is a and this is b, our delta x equals b minus a equals 5 minus 2, and that's going to equal 3. Now that happens to be 3 meters, that happens to be 3 because he's moved in a positive direction. But let's say, for example, instead he moves in a negative direction. He moves to, let's say, -2. Okay, let's have a look at that. So we go delta x equals b minus a. Remember, this is where he was in the first frame. This is where he was in the second frame. This is our a and our b. Delta x equals b minus a equals -2 minus 2, right? -2 minus 2 is equal to -2 minus 2 is equal to -4. Now he hasn't moved -4 meters because you can't move that's not a distance. Distance is always positive. So what we've got to do is we've got to get what we could call the absolute value of our delta position. In the case of one dimension, we're simply talking about the absolute value to get distance. One of the ways we can do that is if we take any number and multiply it by itself, then it's gonna, if it's positive or negative, it'll always be a positive number. Okay, so let's say, for example, -4 times -4 equals 16. That's the same with 4 times 4 equals 16. So now we know, no matter if he moves in this direction or in this direction, if he moves 4 meters in either direction, and we multiply that number by itself, we're going to get a positive number. And then, if we can simply take the square root of that, so we say square root of 16 is always going to be 4. So in other words, what we've done is we've made sure that it's always a positive number. Obviously, square root of 4 times itself is 4, which is kind of the same thing. But the square root of -4 times -4 is 4 as well. So yeah, so I guess what I'm saying is that we're getting the absolute value. It's always going to be a positive number, which means we can apply logic to it. We can say, in a code example, would say like if that distance that we've just worked out, if dist is greater than 5, yay player has moved. Something like that. Okay, so that's distance. Okay, distance is fairly straightforward. We go ahead and write that in. Distance, this is also known as magnitude when we're talking about vectors. And because we're talking about a single number, you could also think of it as simply the absolute value of that single number. So we just say ABS or absolute. So I mean, there's a few ways we could do this. We could just say const dist equals math.abs abs of delta x. That's just going to make sure that if we're going in the negative direction, it'll still think of that as a positive number, a distance between two values. I'm wanting to stay in this frame of mind of saying we're going to do as much as possible by ourselves, working with the numbers as closely as possible. So I'm going to change this. Instead of absolute of dx, I'm just going to say it's the square root of dx times dx. Kind of the same thing, but it's we're sort of thinking about how to manipulate these numbers. Okay, I'm just going to print that distance as well. So dist and then dist, and we'll go ahead and test that out. So yeah, it's essentially the same as delta x, but when we go in a negative position, negative direction, it'll stay positive.